Hello. In this lecture, we will discuss Greibach Normal Form or GNF. In the last class, we have discussed Chomsky Normal Form or CNF. Now, I will give definition of the Greibach Normal Form. So, definition: a context-free grammar or CFG is in GNF or Greibach Normal Form if every production every production is of the form A to A alpha, where A belongs to terminals and alpha belongs to Vn star, that is non-terminals. So here alpha may be null. Now I'll give an example. That means every production is of the form: first it is a terminal followed by a non-terminals. Okay, and this non-terminals may be null. That means only there will be A to terminals. Now we'll give an example. So examples: consider a grammar G with the productions as S to small a, b are null, a to small b, c, b to small b, c to small c. Obviously, all the productions that satisfy these rules, first it is a terminal, and followed by the variables, or maybe null. Here it is a null. So now it is in GNF or Greibach normal form, because it generates terminal string also. So now is in GNF. But this production, suppose we consider another grammar, suppose G1, whose productions are of the form S to AB, A to small a, or b, or small b, b to small b. Obviously this grammar is not in GNF, not in GNF, because this production rule does not satisfy the definition of the Greibach normal form. Now we'll give a lemma. So lemma 1, let G be a context-free grammar where Vn sigma p s be a context-free grammar. Also let there is a to b gamma production. That means A to B gamma be an A production in production rule P of the grammar G. Also there is a B production of that form B to beta 1, beta 2, beta s. Here we define production in the new form, that is P1 is equal to P production in the set P difference A to B gamma union A to bi gamma such that 1 less than equal to I less than equal to S. So then we'll obtain a new grammar. So then grammar G1 whose tuples are Vn, sigma, the new grammar production rule P1 and S is in or is a context free grammar equivalent to the grammar G. Now this lemma 1 is basically useful for deleting variable b appearing as the first symbol on the right hand side of some A productions, provided no B production has B as the first symbol on the right hand side. For example, we'll give an example. Suppose how we basically obtain this grammar, or we use the lemma 1. Let some grammar G whose productions are of the form A2 BAB, and there is a B production of the form B2 AA BB or AA. These productions are given. So in this case, it is of the form, right? This production A2 BAV can be a form of like that, A2 B gamma, and B productions can be written as B. It is, we can consider it is a B1, you can consider it as a B2, we consider it as a B3, and also the condition that no B production has B. Look here, in this B production has no B as the first symbol on the right hand side. Clear? So now using lemma, then using lemma 1 what we can obtain. So this A2 BAB should be eliminated as per the rules. P1 is the new production rule for the grammar G1, where the productions will be like that. This kind of production will be difference. Set difference will be this, and it will include this production A2 beta I gamma. I vary from 1 to S. So we can write the productions. A productions will be this. So this will be basically replaced by beta 1 gamma, right? So we can write AB or B AB or AA AB. Clear? So these are basically the B is basically replaced by this beta 1, this is beta 2, this is beta 3. So and this is basically the gamma. So it is basically, we can say beta 1, this is gamma, this is beta 2, this is gamma, and this is beta 3, and this is gamma. So now this is the A productions, and B productions will be this A to A, B to B gamma, B beta, B to AA or BB or AA. Clear? So by using this rule, we have deleting the variable B that appear as the first symbol on the right hand side of some A productions, and provided no B production has B as the first symbol on the right hand side. So using this rule we can do this, or lemma we can do this. Now we'll define another lemma. These two lemma are basically useful for converting a context free grammar to its corresponding GNF or Greibach normal form. So now we'll discuss the lemma 2. Lemma 2. So here also we consider, let G be a grammar, suppose Vn sigma P S, be a context-free grammar, and let the set of A productions B. We consider the A productions are of the form A to A alpha 1, A alpha 2, A alpha R, then beta 1, beta 2, then beta S. Condition is beta I do not start with A. Here condition is beta i's are not start with A. Now in this scenario, we introduce a new variable and we consider that let z be a new variable. Now the new grammar G1 is basically Vn union this variable z comma sigma p1 and s. So with p1 is defined for this new grammar as follows. So now we define the production rules that will be included into the new grammar G1. So first rule 1 is the set of A productions, the set of A productions in P1 are. What are the production? A productions? A productions that are included into P1 will be A2, beta 1, beta 2, or beta S, and A2, beta 1Z, beta 2Z, and beta SZ. Number 2, the set of, so these are the set of A productions. Now the set of Z productions. Z productions in P1 will be are Z2 alpha 1, alpha 2, alpha R, and Z2 alpha 1Z, alpha 2Z, and alpha R Z. And number 3, the productions for the other variables are as in P. So the productions for the other variables are as in P. Then G1, the new grammar, that is G1, is a context-free grammar and also equivalent to G. So then G1 is in context-free grammar and equivalent to the grammar G. Okay. Now we will give example corresponding to the lemma 2. Let the productions of some grammar G is of the form A, B, D, or B, D, B, or suppose small c, right? And the productions are A2, AB, or AD, right? So now these productions using lemma 2, so we can consider that this A to A, so it is a production of the form alpha 1, A to A, it is alpha 2, and we can consider that no, on the right hand side there is no symbol A appears as a first symbol, right? So A2, this will be considered as beta 1, it will be considered as beta 2, and it is a beta 3. So here what we have obtained, basically alpha 1 is equal to B, alpha 2 is basically D, and beta 1 is equal to A B D, beta 2 is basically B D B, and beta 3 is basically small c, right? So as per lemma 2, so the productions, so the new productions are, so new productions are, first we write by using this the set of A productions, right? The set of A productions, it will be A to beta 1 goes to this production, A to beta 1, beta 2, and beta s, and then beta 1 z, beta 2 z, and so on. So it will be A to beta 1, that means A B D B D B or small c, and A to A B D Z B D B Z and C Z C G, right? So here Z is basically a new variable, and by the condition 2, the set of Z productions that are in P1 will be, so number 2, Z productions will be here Z2 alpha 1 alpha 2, that is B or D, also Z2 DZ and DZ. Clear? So by using this rule, so all other production will remain same. So these are basically two rules. Clear? So lemma 2 and lemma 1 will be used to convert a context-free grammar to its corresponding GNF or Greibach normal form. So look here in this okay, two productions are there. Now we'll define a theorem, or we state a theorem for every context-free grammar, with null does not belongs to the language generated by this grammar G, then there exists an equivalent grammar G dash in GNF or Greibach normal form, or GNF. Okay, so this is the theorem. Now how we construct, given a context-free grammar G, right? Suppose this is a context-free grammar G, and there exists an equivalent grammar G dash in Greibach normal form. Now we have to convert this context-free grammar G to its equivalent Greibach normal form, that is a G dash. Now to construction of this G dash, so construction of G dash. There are some steps to construct G dash. Number 1, we have to eliminate the null productions. So eliminate null production, eliminate null productions, and construct uh, a grammar G in CNF. First, we have to, if there is a null production, so you have to first eliminate these null productions. Then the grammar should be converted to the CNF or the Chomsky normal form. If it is not in the CNF, then we have to convert it. Right? Now, we have to rename. So we rename the variables. Rename the variables as A1, then A2 up to AN. And we have to start from S, that is with S will be A1. So now if we do this, so G dash will be the new grammar where the variables will be like that A1, A2 up to N, and terminals, then productions will be P1 and A1 is the start symbol. So step 1 we have to do this. Now step 2. In step 2 we have to convert, that is to get the production, to get the productions in the form. Which form? We have to convert the productions of this form A to A gamma or AI to AJ gamma with J is greater than or equal to I. So now if we want to find this form, then we have to convert AI productions to the form, which form? AI to AJ comma where J should be greater than or equal to I. We have to convert AI production in this form. So this is the step 2. Now in step 3, convert AN productions to the form A into A gamma, A into A small a gamma. So here the productions of the form A into A n gamma are basically eliminated, right? And obviously to do this, lemma 2 will be used here. Yeah, so here lemma 2 will be used. And step 4, we have to modify the AI productions to the form AI to A gamma for I equal to 1 to up to n minus 1. Similarly, step 5, modify the Z production. Modify the ZI production to the form where Zi to A gamma. So in step 4 and step 5, lemma 1 will be used. Now we'll give an example how these steps are basically implemented to convert a context-free grammar to its corresponding GNF form. So now suppose we have a grammar G whose productions are of this form S to AA or small a and A to SS or small b. Obviously, this context-free grammar is not in GNF. So, as the given grammar, obviously the given grammar is in CNF. If not, then we have to convert it corresponding CNF. And we have already discussed in the previous lecture that how we convert a context-free grammar to its corresponding CNF. Now, as this grammar is in CNF, so as the given grammar or given grammar is in CNF already CNF, so it is not necessary to convert and we rename. So as per step 1, so it is basically the, we can consider that is step 1, we rename the variables, right? And we have to start S with A1, right? So we rename the variable, we rename the variables S, we rename as A1 and A rename as A2, rename as A2. Clear? So now step 2. In step 2, we just write the productions by renaming. So S is basically A1, so A1 to A is A2 or A. Now the A productions, A, it is basically A2 to A1, it is A1 B. Now as per the rule in step 2, as per the rule of step 2, this is step 1, yes, this is step 2, we have to convert AI productions to the form AI to AJ gamma, where this J should be greater than or equal to I, right? So in this production, production rule, look, AI, here I is basically 1, here A2, I is 2, obviously that will satisfy this condition. What is the condition? AI to convert basically AJ gamma, where J is greater than or equal to I, this condition is satisfied for this production. But this production basically not satisfy this condition, where J is not greater than, here it is I, it is J, it is I, it is J, it not satisfy the condition. So what we need to do here, we just put here this, the value or on the right hand side production A1 here. So it will be look like this, that A2 will be, if we put this the value of A1 first symbol by this, it will be A2 A1 or A1. Clear? So these productions, look here, A1 A2 or A, and this modified A2 productions is basically A2 A1 or A2 to A1. Clear? So total A2 productions will be basically, if we write, it will be B. Clear? This B are basically written here. So A2 basically after modification, A2 will be this. Okay. Now we go to the step. So look here, greater than or equal to. So all the production, these productions and these productions satisfy this condition. Equal to condition has been satisfied. Now we go to step 3. And step 3, this A2 productions, clear, A1 productions will be have no problem, but go to this production here. this production A2 to A2 on the right hand side. The first symbol is A2, right? So A2, so as A2 productions of the form is basically A2 to A2, A2, then A1, A1 or B. So we can consider that this A2, it is basically of the form A2, A, alpha 1, or this is beta 1. We can consider this is beta 2. Now we consider that Z2 be a new variable. So let Z2 be a new variable we consider. So these productions will be, so A2 will be A2 beta 1 beta 2. So A1 or B, and A2 to A1 Z2 or B Z2. So these are basically using the lemma 2, right? Go here, the lemma 2. This is basically lemma. If sorry, this is basically lemma 2 of the production A2, A alpha 1 alpha 2, then it will be written as this form A alpha 1. So we have to introduce new variable, that is Z2, and A productions will be A2 beta 1 beta 2 and beta 1 Z2 beta 2 Z2. So these are basically A productions. Similarly, uh, Z. So similarly, Z2 productions will be Z2 alpha 1. So A2 A1 or alpha 1 Z2. So A2 A1 Z2. Clear? So these are basically, after step 2 we have obtained these productions. Now step number 4. What actually step number 4 says? Go to the rules. Step number 4. Step number 4, modify the AI productions and modify the step number 5, modify the ZI productions. So that it will be of the form AI to A gamma or ZI to A gamma form. So now step number 4. So the A2 productions are, we write again A2 A, A1 or B or A1 Z2 or B Z2. We have obtained this. So now the modified, because these are the A2 productions, and in the first case, look here, this A1 productions we have to, so all the AI productions will be modified. AI means I, basically there is a two variables A1 A2. So I equal to 1 and I equal to 2, you have to modify this. So A2 has been modified and we have to modify the A1 productions. So modify the modified A1 productions. Modified A1 productions are, what will be these productions? Look here, A1 to A2 A1 or A, these productions. Now this A2 will be replaced by this A1 B or A1 Z2 or B Z2. So the new A1 productions will be A1 to A, A1 A2 B A2 A, A1 Z2 A2 B Z2 A2. Clear? And all other production will remain same. Same means Here this A1 to A will remain same. So another production will be here, another form A1 to A, right? So now A1 production, modified A1 productions will be this. Now step 5, we have to modify Z2 productions. So modify Z2 productions. Now Z2 productions are, this is Z2 production, right? This is the Z2 productions, and in Z2 productions A2, and this is also A2. So this A2 will be modified or will be replaced by this A2. These values A1, B, A1, Z2 or BZ2. So the modified Z2 productions will be Z2 equal to A1, then A1, or B A1, or A1 Z2, then A1, B Z2 A1. Clear? All this is Z2 productions, and so another Z2, this A2 will be replaced by this, again same values. So it will be these values A1 and A1 Z2 and A1 Z2. Similarly, B A1 Z2, A1 Z2, A1 Z2, B Z2 A1 and Z2. Clear? So these are the modified productions, Z productions, and these are the modified A productions. So look, in every production on the right hand side, it satisfies the properties of the GNF. Look here, A, then variable, B, A, all are variable, here B, and then variable. Here also, first is a terminal, then followed by variable, terminal, variable, terminal, variable, terminal, variable, and it is a terminal. Similarly, Z productions will be terminal, variable, terminal, variable, terminal, variable, terminal, variable. Here also terminal, variable, terminal, variable, terminal, variables, terminal as well as variable. Hence, the equivalent grammar is, that is a G dash, as we have mentioned. Here the variables will be A1, A2 and Z2, right? And the terminals are AB, and production is P1 and A1 with P1 as. Okay. So as means we have to give all these A1 production, A2 productions, then Z2 productions, also Z2 productions. So all the production will be included here. So finally, we can write that the production E1 to A1, A2, B, A2, A1, then Z2, A1, B, Z2, A2. And A2 production will be A1, right? Then B, then A1, Z2, B, Z2. Okay, and now the Z2 productions will be A, as we have mentioned here, all these two productions will be there. So A1, A1, B, A1, A1, Z2, A1, B, to A1, and finally Z2 productions A. Both are same here. Both the Z2 productions we can include on the right hand side by using order, but here we can also write in different way. A1, A1, Z2, B, A1, Z2, A1, Z2, A1, Z2, and B, Z2, A1. Yeah. So we can combine this Z2 production into a single one. So this is basically the grammar. Uh, it is in GNF form. So it is in GNF or Greibach normal form. So it is in GNF. Okay, all productions are basically satisfy the condition A2. What is the production form? A2 A gamma. As we have mentioned that in Greibach normal form, the production form is A2 A gamma, or also you can write the alpha, that whatever we have defined in the first. So into alpha, and here A is the terminals, and alpha basically belongs to variables. That is, A belongs to terminals and alpha belongs to Vn star, or alpha may be null or empty. So these are the basically the steps. Look here, these are steps how we convert a context-free grammar to its corresponding Greibach normal form or GNF. So first, if there is a null production, we have to remove these null productions. And if the grammar is in CNF, then no problem. But if the grammar is not in CNF, then we have to convert it into a CNF, and then we rename the variables. And step number 2, we have to convert all the productions of this form AI to A gamma or AI to A J gamma. Convert all the AI production of this form AI to AJ gamma, where J should be greater than or at least equal to I. If not, then we have to substitute the values so that it will satisfy these conditions. AI to AJ gamma with J should be greater than or equal to I. Once we have completed that all the AI productions of this form, then we go to step 3. We convert AN to A gamma, AN production. That means AN productions of the form, that is AN on the right hand side, there is an AN. So this type of production here, this AN will be eliminated. Eliminated. So lemma 2 will be used. This kind of production will be eliminated. AN to AN gamma. So lemma 2 basically will be used here. And now we modify this AI production, whatever obtained in step 3, we have to modify these productions of this form. Similarly, we have to modify the Z productions. And to modify AI or ZI productions, we have to substitute the values of A2 or A1 or similar Z2 or Z3, etc. Whatever be the values, we have to replace by this, so that the total or entire production form will be of this, where first symbol is a terminals and remaining are basically the variables. So thank you.